All right, welcome to the second lecture in Unit 7. It says, what's your type? And it says there are two kinds of people, those who do the work and those who take the credit. Try to be in the first group. There's less competition there. So when we're looking at this, we're looking at the types of chemical reactions. So the learning goals that we have, students will classify the types of chemical reactions by examining the products and the reactants. So we're going to look at the products and the reactants, and we're going to figure out how those really go together to classify the types of chemical reactions. And then we want to classify the reactions as oxidation reduction, precipitate, or neutralization based on the electron movement. And that's kind of a little bit harder, but we're going to look at those. So what we already know, that chemical compounds will react to form bonds that are more energetically favorable. And so the reason why chemical reactions take place is because that atoms and elements are trying to find the most energetically favorable state. They're going to react to form something that's most stable. And so all chemical reactions follow the law of conservation of mass. We know that because we talk about a balanced chemical equation. So this is what we already know coming in. What we learned in the lab is that chemicals will release or gain energy in a chemical reaction. We call this endothermic or exothermic reactions. And that chemical compounds can combine, break apart, or rearrange according to form new substances. And so when they're doing this, everything's going to rearrange so that it makes something new and most energetically favorable. So the types of reactions. So how many different types of reactions or chemical reaction exist? Well, the minimum estimate of possible chemical compounds is 10 to the 18th power. So that's a lot. And so this makes the number of possible reactions practically infinite. So you can have as many chemical reactions you can possibly think of. We're going to talk about first the 5 major types of reactions. We have synthesis, decomposition, single replacement, double replacement, and combustion. So these guys are in general the 5 major types, 5 general types of chemical reactions that we can kind of classify everything as. So when we're looking at the types of reactions, it's all about the reactants and the products. So when we're looking at the type, we look at the reactants, we look at the products. How do the reactants change? Do they combine, separate, or switch partners? How do they react with one another? And how does reactants compare to the products? So when we're looking at the types of chemical reactions, we have to really look at reactants and products and what's actually happening. So in a synthesis reaction, if the reactions form a lower number of products, you have a synthesis reaction. The way you can think of this, if we're going from 2 things all the way into 1 thing, then normally what we're going to have is we're going to have a synthesis reaction. The main thing you can think of, if you have multiple reactants and then only 1 product, that's going to be a synthesis reaction. Or you can also call this a combination reaction. An example of this would be we have magnesium plus oxygen produces magnesium oxide. That's a synthesis reaction. And we can normally say that the molar mass of the substance increases. So the product that we have, this molar mass kind of increases in that one simple thing. Do we have an increase in mass? Remember, it follows the law of conservation of mass, but that one substance is generally going to have a larger molar mass than just the 2 things by themselves. When we're looking at a decomposition reaction, if the reactants form a higher number of products, you have a decomposition reaction. So if I go from 1 thing to essentially 2 things, we see that we have a decomposition or breaking apart. When we look at this, we can think of water. If we take water and break it apart into the hydrogen and the oxygen, we see that it's broken up into its pieces, and so therefore what we have is we have multiple pieces coming from 1 thing. It broke apart, so it's a decomposition reaction. And in general, what we see is that the molar mass will decrease going from this 1 large substance to smaller substances. In a single replacement reaction, if a single element switches places with a similar element in the compound to produce a new product, we have a single replacement reaction. You can kind of think of this, if you normally have an element plus a compound, it produces a new compound plus another single element. And you can kind of think of this, the equation that we have for it, this E switches places with the D. And so now the E is bonded to the F and the D is by itself. And those are just letters that represent chemicals. So in this case we have iron reacting with copper 2 sulfate to produce copper all by itself, and then iron 2 sulfate. And so we can see that they replace each other. The iron replaces the copper. So now copper is by itself and iron is in the compound. If two compounds in the reactant switch partners to form two new compounds in the products, you have a double replacement reaction. And we can look at this. G was bonded to H, and now G is bonded to J, and they just switch partners. An example of this would be lead 2 nitrate plus potassium iodide produces that potassium nitrate and that lead 2 iodide, and you can really see a nice color change there. So going from aqueous substances of those guys, mixing them together, and we see that we have a nice chemical reaction. And then lastly, of the 5 major types, we have combustion reaction. So if oxygen reacts with a compound to produce heat, carbon dioxide and or water, what we see is we have a combustion reaction. And this just has to be oxygen pretty much reacting with anything else. It produces, if it's a hydrocarbon, meaning some carbon hydrogen bonded together, it's going to produce CO2 and H2O. An example of this is just methane reacting with oxygen. That's what's in Bunsen burners. When you light a Bunsen burner, it produces carbon dioxide and water. That's a combustion reaction. Anytime you see just carbon dioxide and water on one side of the reaction, you can kind of think, hey, did a combustion reaction happen here? So let's look at a proficient level question. So on this, it says classify the following reactions as synthesis, decomposition, single/double replacement, or combustion reaction. So on our very first one, we can look, we see that we have aluminum and we have iron nitrate, and then what do we see? We see that aluminum switches places with the iron, and so that is a single replacement. Okay, here we have CH4 reacting with O2 produces CO2 and H2O. That would be a combustion reaction. Here we have potassium chlorate, and it breaks apart into potassium chloride and oxygen gas. We see that that would be a decomposition reaction because we're going from one thing to two things. Here we have pure iron reacting with oxygen to produce iron 2 oxide, and we see that we go from two things to one thing, so that would be a synthesis or a combination reaction. And then lastly, we have NaCl plus NaOH produces NaCl and H2O, and you kind of think, well, hey, wait, what happened? Well, that H went with that OH, switch partners, and HOH is H2O, and so that would be a double replacement reaction. Next example, it says describe the types of reactions involved in the isolation of copper. So in our first one, it says copper 2 nitrate is combined with sodium hydroxide to produce copper 2 hydroxide and sodium nitrate. So here's one reaction. And it says the copper 2 hydroxide is heated to produce copper 2 oxide and water. Well, that is another reaction. And it says the copper 2 oxide is then added to sulfuric acid to produce copper 2 sulfate and water. There's another reaction. And it says then zinc is added to the copper 2 sulfate, and the zinc sulfate and copper metal forms. And lastly, that would be the last reaction. So looking at each piece of these, then we can kind of break it apart. We have copper 2 nitrate, that's a compound, is combined with sodium hydroxide, that's a compound, to produce copper 2 hydroxide, that's a compound, and sodium nitrate, which that is a compound. So we can see that the sodium was bonded to hydroxide, now it's bonded to nitrate. Well, when we're seeing all of that, they switch partners, so that is a double replacement. In the next reaction, it says the copper 2 hydroxide is heated to produce copper oxide and water. So one thing is heated up to produce two things, which that would be a decomposition reaction. Then it says the copper 1 oxide is then added to sulfuric acid. That's a compound, that's a compound, and produces copper 2 sulfate and water. So it produces two other things. Well, the copper was bonded to oxide, now it's bonded to sulfate in the sulfuric acid, and we see that we have another double replacement. And then lastly, zinc is added to, which zinc is an element. It's added to copper 2 sulfate, and zinc sulfate and copper metal forms. So we see that the zinc replaced the copper, so that is now a single replacement. So there's a lot of chemical reactions going along in that paragraph. Keeping up with those. So the next one, when we're looking at these, we want to organize or organizing reactions. We really ask ourselves, are the 5 major types the best way to categorize the chemical reactions? And really the answer is no. Chemists classify chemical reactions based on electron movement. So we can kind of think the 5 major types, they take care of pretty much everything, but there are some types of reactions that it's more we can be more specific, and it's better to look at electron movement than it is just to look at everything else. So chemical reactions occur because of the interactions of valence electrons. So to describe everything, where we can have everything described by one single thing, we can really look at electron movement. The standard reactions that really what we have is we have oxidation reduction reactions, we have neutralization reactions, and precipitation reactions. And what we can see is that the major types really fit in with all of these, and we can just organize these by oxidation reduction, neutralization, and precipitation, and it covers everything. So oxidation reduction reactions, they can be single replacement, they can be synthesis, they can be decomposition, and they can be double replacement reactions. Now, neutralization reactions, it's a specific type of double replacement reaction. And then a precipitation reaction is a specific type of double replacement reaction. And so what we can do is we can categorize every chemical reaction by these 3. The 5 major general types, the synthesis, decomposition, single replacement, double replacement, combustion, those guys, they leave out a couple things. So in general, what we do is we'll organize in high school and on-level chemistry with single replacement, double replacement, synthesis, decomp, and combustion. But we're going to talk a little bit about oxidation reduction, neutralization, precipitation. So oxidation reduction is any type of reaction where the oxidation numbers change in that reaction. So oxidation numbers change in an oxidation reduction reaction. So solid iron, and it goes into an aqueous substance, it becomes iron 3. Its oxidation number changed. When it's an element at 0, now it's plus 3. Well, to become plus 3, the electrons had to move. One thing we will point out, all single replacement reactions are oxidation reduction reactions. Okay, that's one thing to point out, because if we have a metal and it replaces something, then it's going to change its oxidative state. So when the oxidation numbers change, you have an oxidation reduction reaction. Now, precipitation reaction is when a double replacement reaction occurs in a solution. And if a solid appears in solution, you have a precipitation reaction. So we have a solution here, and if we combine it with another solution, and then you have a precipitate, precipitate is what that solid that falls out. So when we're looking at this, all of that yellow stuff is a precipitate. We put 2 liquids together that didn't have any color to them. They were both clear, and then we see a solid. We use solubility rules to really determine if this happens, and we'll talk about that in the next lecture. But right now, all you really need to know is if a solid appears in solution, you have a precipitation reaction. And then a neutralization reaction. If the reactions are composed of acids and a base, then you have a neutralization reaction. So if you put an acid and a base together, you neutralize it. That's what we call a neutralization reaction. So questions that we have: what is an acid? For now, acids are anything that extra free floating hydronium ions in an aqueous solution. A hydronium ion is what you look at right here. You can think of kind of in general anything that kind of starts with hydrogen, like H2SO4 starts with hydrogen. Guess what? It's probably an acid. Or HCl, that's an acid, starts with H. So for right now, what is a base? Bases are anything that has extra free floating hydroxide ions in aqueous solution. For right now, potassium hydroxide, guess what? Base, because it has that OH. For right now, when we're looking at it, we have NaOH. Guess what? Base. It has that OH. So if you kind of see something that has an OH and then you see something with an acid, that's a neutralization reaction. And we're going to get into this a lot more in detail when we talk about acids and bases in a later unit. But just be aware that there are neutralization reactions. So looking at an example, it says a basic liquid battery can be made using the reaction below. Identify what type of reaction this is. So when we're looking at this, it's a single replacement reaction because we see the copper replaces the zinc. And when we're looking at this is there's going to be a transfer of electrons. That's how a battery works. But any single replacement reaction is an oxidation to reduction reaction. So any single replacement that actually occurs, oxidation reduction. So we can classify it as oxidation reduction, or we can look at it and just say, hey, single replacement. The next one, it says titration is a useful procedure in a chemical analysis. What type of reaction is a chemist investigating if drops of titrant are added until a solid appears? So when a solid appears, that means that a precipitate's appeared, and so therefore that is a precipitation reaction.